So, we've been talking about how to execute scripts across thousands of machines. We've done traditional PowerShell remoting with the WinRM service and also OpenSSH. Now, in the last section, we're going to talk about group policy. Using group policy, you can configure nearly every configurable setting in Windows. And with enough domain controllers, you can make this literally scale to, for example, 100,000 machines. In the security course, many of the changes that we can make through group policy. So we don't want to configure our boxes by hand. We don't want to turn our machines into something like handcrafted works of art. Instead, we need tools that can scale out across thousands of boxes and continuously reapply the security settings that we want. And the two main tools for this course are group policy and PowerShell. Group policy, for example, continuously, or rather every several hours, reapplies a small set of security settings, but you can expand that so a larger set of security settings are reapplied over and over again, even if they haven't changed in the group policy object itself. Now, how does this relate to PowerShell? We can use group policy to manage the security settings related to PowerShell. But even better, we can use group policy to execute PowerShell scripts on our machines. So, PowerShell remote execution includes the WinRM service, the OpenSSH service, and also group policy. Our main graphical tool for managing group policy is the Group Policy Management Console. There's different ways of getting to this console on your machine. One way is this. Please go to PowerShell and run mmc.exe, MikeCharlie.exe. I know that there's other ways of getting to the Group Policy Management snap-in. Actually, it's actually not a console. But we want to create our own custom MMC consoles this week. Later on, we're going to talk about why. So in PowerShell, please run mmc.exe. This will launch a graphical tool, and in this graphical tool, you can add snap-ins. Now, a snap-in is a management tool that snaps into or plugs into this graphical wrapper, the MMC console. So please pull down the File menu and select Add Remove Snap-in. So on your machine, please run mmc.exe. Once the console appears, pull down the File menu, go to Add Remove Snap-in. Now in your list of snap-ins, please scroll down and you'll see that you have several snap-ins that have the words Group Policy as part of the name of the tool. Well, we want the first one, the one that says Group Policy Management. You may have to grab the column header at the top and drag it off to the right so you can see it better. So please select Group Policy Management and add it to the right-hand side. There's another snap-in that we want. This one is named Group Policy Object Editor. Group Policy Object Editor. Now when you select that snap-in and click on Add, it'll ask you which group policy object do you want to edit. We want the local computer GPO. That's the default. So just click on Finish. And notice that when you've added the snap-in, it renamed it. So the original name of the snap-in is Group Policy Object Editor, but once you select a particular GPO, it'll rename the snap-in. So now it says Local Computer Policy. Click on OK. And now we've added two more snap-ins to our console. We're going to add more snap-ins to this console during the week, so let's save our changes. Please click on the File menu now. Go to Save As. Select your desktop. And please name this file Tools. So again, I pull down the File menu. Save As. Select your desktop, and at the bottom for the name of the file, please name it Tools. That'll create a file named tools.msc on your desktop. Now, whenever you need your custom console, you just double-click that file on your desktop, it'll appear, and we can add more snap-ins to the console during the course. I'm now going to maximize that window, the MMC console, so it takes up my whole screen. Please go to the Group Policy Management snap-in in your console. When you expand it down by clicking on the little arrow to the left, you'll see a list of all your forests. In this case, we only have one forest. It says testing.local. When you expand down your forest, you can then expand your list of domains in your forest. And in this case, we only have one domain in the forest, testing.local. Please expand that downwards, and you'll see the yellow organizational units in your domain. In your list of organizational units, please go to East Coast and then select Boston. The Boston OU is kind of like our sandbox or playground where we can make changes with group policy and we don't have to worry about it breaking anything. On your machine, let's create a GPO and link it or apply it to the Boston OU. Please right-click on the Boston OU, select Create a GPO in the domain, and link it here. So I've gone to my domain, testing.local, expand it down, East Coast, and then you can see the yellow folder, that's the Boston organizational unit. Please right-click on the Boston OU, create a GPO in the domain. Now for the name of the GPO, let's name it Boston_character GPO. GPO stands for Group Policy Object. When you click on OK, you can now expand down the Boston OU and you'll see the Boston GPO. It looks kind of like a music script with a little arrow on top of it. Technically, this is the link to the GPO. When you click on this for the first time, you'll get a pop-up dialog box talking about the link. Check the box to say, don't show this message again, and then OK. Now, what exactly have we done here? What is a group policy object anyway? Well, a GPO is like a little database of configuration changes. Inside of a GPO, you have approximately 3,000 settings that can be modified, and you could add thousands more if you want to. To see or edit the configuration changes inside the GPO, please right-click the group policy object now and select Edit. So please right-click the Boston GPO and edit. Now when you right-click and edit, you get a whole new MMC console, but this shows the settings inside the GPO. Inside the GPO, you'll find hundreds of containers and thousands of icons for different configurable settings. Throughout the week, we're going to talk about security settings that you'll find in group policy objects, and in your manuals, it'll have the path to where you can find a GPO setting. So that's a quick taste of the Group Policy Management Console. This is our primary graphical tool for creating and editing group policy objects. You can also find this if you go to Server Manager and pull down the Tools menu. In fact, that's why we saved the custom console and named it Tools and saved it to the desktop. So your choice. If you want to go to Server Manager and pull down the Tools menu, you can launch Group Policy Management from there. But generally, I'm going to stick with the Tools console that we just created on the desktop. You can also partly manage your group policy objects in PowerShell. You may have heard that group policy objects cannot be applied to standalone machines, and that is false. That is not true. LGPO.exe, that's a free tool you can download from Microsoft, and that allows you to apply a group policy object to a standalone machine. There's also third-party enhancements or extensions for group policy to make group policy do more than what it's originally designed to do by Microsoft. Just as an example, Policy Pack allows you to apply group policy objects over the internet. And Centrify has a suite of tools that allows you to join Linux and Mac OS machines to the domain, and you can partly, not fully, but partly manage those devices with group policy as well. So group policy really is more of a management framework as opposed to one specific tool. I know many of you are familiar with group policy already, but I think it's beneficial to do at least a couple slides on the overview of the mechanics of group policy. And then, when we get to the PowerShell part, we'll slow down and focus on that, and then do some labs. So, as a quick overview, how does group policy work? Well, when your machine boots up, it talks to a domain controller and asks, are there any group policy objects that apply to me? And if yes, the machine will download and apply that GPO. Again, you can think of a GPO as like a little database of configuration changes. So the machine downloads and applies those configuration changes to itself. This happens automatically. Now let's imagine hours later a user logs on to that machine. The machine will contact the domain controller again and say, hey, user X, let's say Alice or Bob, has logged on to my desktop. Are there any group policy objects for this user? And if the answer is yes, the machine will download and apply the group policy object. In this case, we're probably reconfiguring the user's desktop or the user's applications. Now, approximately every 90 to 120 minutes, so roughly every 2 hours or so, your machine will contact the domain controller and ask, have any of my group policy objects been modified? And if so, the modified portions will be downloaded and applied to the machine. Now, if you're familiar with group policy, as you know, some changes don't take effect until after you log off and log back on, and there's even some changes that don't take effect until after you reboot the machine. But technically, the changes are downloaded and applied, it's just that they haven't taken effect yet. There's a small number of security settings that are reapplied every 16 hours, even if they've not been modified in the group policy object. Now the question is, which group policy objects does my computer download? Or when I log on, which group policy objects are applied to me? Well, what we need is some kind of targeting system, some way of saying that I've got these 2 group policy objects and I want them applied to these users, and I've got these other 2 group policy objects and I want them to be applied to these other users, and so on. Well, I go back to my MMC console. Now, for example, we're editing the Boston GPO. As you can see, I can drill down through all the subcontainers, and for example, I've just selected one of these things at random. And off to the right-hand side, I have Cipher Suite Order. Again, this is just something I selected at random. It doesn't matter. But this is a setting perhaps I want to apply. So I double-click. On the right-hand side, I usually get a short description of what this setting is for. I can set it to enabled, and notice on the left-hand side, you might have a menu, a text box, radio button. In this case, I have a text box where I type in some text or paste in some text. So in real life, I would make a change here and then click on OK. I'm just going to do cancel. I've now modified my GPO. I close the window. So my Boston GPO, let's imagine, now has some configuration settings inside of it. Well, the Boston GPO is linked or applied to the Boston OU, and that's indicated here in the graphical interface by the GPO being immediately underneath the Boston OU. So you can right-click organizational units, like for example, if I come down here to Europe and then Heidelberg, I can right-click an OU, create a GPO. I might call this one Heidelberg GPO. You don't have to do this on your machine. This is just an example again. And I've now created a new group policy object and applied it to Heidelberg. Well, in that GPO, I could have completely different settings. The Heidelberg GPO applies to the Heidelberg organizational unit, and the Boston GPO applies to the Boston OU, and those 2 group policy objects could have totally different settings. What if I want to apply a change to the entire domain? Notice at the very top here, underneath testing.local, I've got domain default policy. I can right-click and edit that GPO just like any other one. I can make some configuration changes inside this GPO. And because that group policy object is linked or applied to the domain as a whole, then at least by default, it applies to every single machine and every single user in the domain. There's one last place where you can apply group policy objects in Active Directory. Down at the bottom, I can see the sites container. By default, you can't see any sites, but if you right-click on sites, you can go to Show Sites, and then you can check the boxes for the names of the sites that you want to see. In this case, I've just selected them all. You don't have to do this on your machine, it's just an example. Now I could select, let's say, the Dallas site or the Fort Gordon site. I can right-click on a site and then link or apply an existing GPO. For example, there's that Heidelberg GPO that I created a few seconds ago. And that shows that a single group policy object can be applied to multiple containers simultaneously. So in this case, I've applied the Heidelberg GPO to the Heidelberg organizational unit, but I've also applied that to a site named Fort Gordon. So these are the three primary containers where you can apply group policy objects. You can apply group policy objects to sites, domains, and organizational units. And the idea is, if your computer is in one of these containers, then you download the associated group policy object and your machine applies it to itself automatically. Again, this happens at boot up, user logon, and roughly every 2 hours after that. You also have a local GPO, by the way. And for example, if your machine is a standalone computer, this is typically the only GPO that you have. We've already added a snap-in to see the local GPO. In our MMC console, we added the group policy object editor snap-in, and then we selected the local computer policy, and that's why the name of the snap-in is local computer policy. This is also a group policy object, but this isn't on your domain controller, this is on your local hard drive. On a standalone computer, this is typically the only GPO that ever gets applied to that standalone machine. In the lab, we're going to edit a group policy object that applies to the entire domain. We're going to make some changes that we can actually see. And at the end of the lab, we're going to get a little bit of experience using PowerShell to manage group policy objects. What happens if I have multiple group policy objects that all apply to the same machine? Which group policy object wins? There's an order in which group policy objects are applied, and later GPOs can overwrite the changes made by earlier GPOs. Now, the acronym to memorize for both real life and the exam is LSDOU. LSDOU, that acronym, that summarizes the order in which group policy objects are applied. Again, imagine you have two group policy objects both trying to configure your screensaver. So the first GPO applies, you get screensaver number 1. The second GPO applies, that overwrites that exact same registry value, and now it's the second GPO that's the winner. So for any configurable setting, the last GPO to touch that setting is the winner. So in what order are group policy objects applied? Well, L stands for a local GPO. Every Windows computer has a local GPO, even standalone machines. The local GPO is applied first, and again, on a standalone machine, that's usually the only GPO that ever gets applied. Now next comes any site GPOs. So going back to my computer, recall that I have several sites on my machine, and let's imagine that my machine is in the London site. Off to the right-hand side, I see that there are no GPOs applied. By default, there are no site GPOs, but we could add them if we want to by right-clicking and then linking an existing GPO. So in LSDOU, S stands for site. It doesn't mean that necessarily you have any site GPOs, but if you have them, now they would be applied. Then D stands for the domain GPOs. In this case, I'm inside the testing.local domain, and sure enough, I do have a GPO applied to the entire domain. So that will be applied next. Now for the organizational units, we have to know what is the target OU that we have in mind. Or for my computer, in which organizational unit does my computer account live? Now let's imagine that our machines are in Boston. There's a Boston GPO, but notice that Boston is inside of another organizational unit, East Coast. Well, I could right-click on the East Coast organizational unit and create a GPO here. You don't have to do this on yours if you don't want to. This is just an example. So organizational units can be nested inside of each other, and organizational units can have 0, 1, or multiple GPOs applied to them. So in LSDOU, D stands for domain, So the domain GPO is applied. Then we work our way down the organizational unit structure. I next apply the East Coast GPO, and then finally the Boston GPO. If the machine that I have in mind, if my target machine or my target OU is Boston, then that would be the last GPO applied. That means if there's any conflicting settings among any of these GPOs, because the Boston GPO is the last one to be applied, that'll be the winner. So what happens then if you have multiple GPOs? Which one takes precedence? Well, the GPO that takes precedence is the last one to apply to the machine and touch that setting. So again, if we think of, let's say, the screensaver, or how about a PowerShell policy, the last GPO to modify that registry value or change that NTFS permission on the hard drive, that GPO is the winner. There are ways to customize all this. For example, if I right-click on the Boston OU and select Block Inheritance, that'll put a blue exclamation mark on top of the OU, and we can see now that Block Inheritance is checked. Now, when you enable Block Inheritance on an OU, you no longer inherit or apply any of the group policy objects that are above you in the Active Directory hierarchy. What that means is that for the Boston OU, I'm no longer applying the East Coast GPO or the domain GPO that's above me. Now be aware that when you enable block inheritance on an OU, that the local GPOs and the site GPOs, those are still processed. But all the GPOs that are above Boston in the Active Directory hierarchy, namely East Coast and the domain container itself at the very top, those GPOs are blocked. You can actually see this here on the right-hand side. There's a tab on the right-hand side that says Group Policy Inheritance. That shows the group policy objects that are applied. And as I right-click on Boston and check or uncheck block inheritance, you can see that group policy objects come and go. So if I turn off block inheritance, I see all three of the group policy objects, Boston, East Coast, and domain. But if I right-click on Boston and enable block inheritance again, well then, those GPOs above me, namely East Coast and from the domain, those GPOs are no longer applied. In general, if there's any doubt about knowing which GPOs will apply to the machines in an OU, go to the Group Policy Inheritance tab and it'll show you the list of the group policy objects that are applied. Now, what if multiple GPOs are applied to the same OU, or the same site, or the same domain? For example, what if I right-click on East Coast again, I create a new GPO, and in this case I'm going to call it, how about East Coast number 2 GPO. So I've got two group policy objects applied to East Coast. By default, both of them will be inherited and applied to the machines in Boston. Now the question is, in what order are those GPOs applied from East Coast? Well, when I click on Boston and I go to the Inheritance tab on the right-hand side, that shows me the order in which the group policy objects are applied. But the strange thing is that you start at the bottom of the list here, and you have to remember that you start at the bottom of the list and you apply them going upwards. Remember, the Boston GPO is the last one to be applied, therefore it's at the top of the list, and therefore it has the highest precedence. That's why it has precedence number 1. It will win out over any other conflicting GPO. And how or why does it win? It's because it's applied last. So the order in which these GPOs are applied, you actually start at the bottom of the list and work your way upwards. Now notice, if I go back to the East Coast organizational unit, and I now go to the left-hand tab, it says Linked Group Policy Objects. Notice that I can select a GPO and I have arrow buttons here on the left-hand side. The little arrow buttons look like gray triangles. And notice that I can reorder my GPOs here on the list. Whenever you see a list of GPOs like this, just remember that you apply the GPO at the bottom and then you work your way upwards. So in this case, I put East Coast number 2 at the top of the list. And that means when I go back down to Boston, I go to the Group Policy Inheritance tab and notice that it's reordered the GPOs there. So that shows that as we're applying GPOs, we start at the bottom of the list, we apply them going upwards. Still, the Boston GPO is the last GPO to be applied, but notice that the 2 East Coast GPOs have swapped their positions. Again, if I go back to the East Coast organizational unit, I click on the left tab, the one that says Linked Group Policy Objects. I can select a GPO, use the up and down arrow buttons, they look like gray triangles. I can change the ordering here. And again, when I go back to the Boston OU, I go to the Inheritance tab on the right-hand side. And again, we can see that the ordering of the GPOs has changed again. Now, if this sounds complicated, that's because it is. And that's also why it's in the manual. This is the sort of thing that will drive you crazy when you're troubleshooting it in real life if you're not aware of this behavior. So LSDOU, that's the overall acronym to memorize. That's the overall order in which they're applied, unless you enable block inheritance, and then you don't apply any of the GPOs that are above you. But one last wrinkle in that story. What if you have a group policy object and you want to guarantee that it is applied to every machine in the domain? Well, here, I'm going to right-click on my domain. You don't have to do this again, this is just an example. I right-click on my domain, I create a GPO, and in this case, I'm going to name it Enforced GPO. So there's a new group policy object applied to the domain. But what makes it enforced is because I right-click and I select Enforced. When you right-click and select Enforced, it puts a tiny padlock on top of the GPO. With an enforced GPO, enforced GPOs are always applied even when you are blocking inheritance at an organizational unit. Or another way of saying it, between block inheritance and enforced, which one's going to win? It's enforced. So even when I enable block inheritance on the Boston OU, here on the right-hand side, when I go to the Inheritance tab, I can see that the enforced GPO, that's still being downloaded and applied. But if I right-click on that enforced GPO, and I turn off the enforced feature, then when I do a refresh here in Boston, we can see that it disappears. Because I've enabled block inheritance on the OU, I block the inheritance of all the GPOs that are above me in the Active Directory hierarchy, except for enforced GPOs. All of this is in your manual. This is way too much to memorize. In this case, most people who take this course have been using group policy for years, so these slides are kind of like a refresher. But I know that if you're totally new to group policy, this can be a little bit overwhelming. Group policy literally could be a whole 2 or maybe even 3-day course all by itself if you really, took a dive into the deep end. There's many other tools and many other bells and whistles for group policy, but we can't spend 2 days on group policy though, especially since most people who take the course have prior group policy experience. So I know that for most of you, this is a bit of a refresher, but I know for some of you, you've never seen group policy before, and this can be pretty confusing. But don't worry, all this is in the manual, plus lots more. Group policy objects are stored on our domain controllers. Group policy objects have permissions. If you can't download a GPO, you can't apply it. So, depending on the permissions on a GPO, the permissions will determine who can download it and therefore who can apply it. Group policy objects have an access control list, permissions, and we can use these permissions to regulate or control which users and computers download the GPO. Here's an example. If I right-click on my domain, I can create a new GPO, and we're going to call this one Only for the Sales Group. Now, normally, when you apply a group policy object to the domain, that GPO is downloaded and applied to every machine and every user in the domain. But I want this GPO only to apply to the users in the sales group. So I select the GPO. On the right-hand side, I go to the Delegation tab, and at the very bottom right-hand corner, I click on the Advanced button. So I've selected a GPO, gone to the Delegation tab, and at the bottom right-hand corner, I'm now clicking on the Advanced button. When I click on Advanced, it shows me the permissions on the group policy object. Notice that the Authenticated Users group has the Read and Apply permissions. But what if I were to uncheck the box for Apply? Now Authenticated Users only has Read. But to apply a group policy object, you have to have both. To download and apply a GPO, you have to have both the Read permission and also the Apply group policy permission. I want that GPO to be downloaded only by members of the sales group. So I click on Add, I type in the name of the group, in this case Sales, and for the sales group, I give it Read and Apply. So if you were to go through and examine all these permissions, you'd see that the only group in the domain that has both Read and Apply is the sales group. We can also use this to explicitly deny access. So for example, if I click on Add, I could type in the name of a group like, for example, the Guests group. I now select the Guest group, and I can explicitly deny the Apply permission. So just in case someone is a member of both the sales group and the Guest group, they won't get the GPO. That's because the deny takes precedence over the allow. Now, can computer accounts also be members of groups? Yes, they can. So imagine that you create a group called SharePoint servers, and you add the computer accounts of the SharePoint servers only. You could now target a group policy object only to that one group of computers. So one way to lump machines together is into organizational units, and you can apply a GPO to the OU. But you can also lump computers together into a global group. And by modifying the permissions on the GPO, we can apply that GPO just to the machines in that global group. The main thing to get from this is that group policy objects have permissions. If you can't download a GPO, you can't apply it. We can put our users and computers into different groups and then assign them different permissions. In other words, it's another targeting system that we have. It's another way that we can apply different group policy objects to different groups of users or computers. Now, why do we care about this? Why are we talking about it at all? Well, first, because we're going to discuss Windows security and PowerShell security, and we're going to use group policy to manage many of these security settings. So for example, many times throughout the rest of this week, we're going to go back to group policy and use group policy to make some changes. So this is not the only group policy material. There's several labs coming up over the next few days where we're going to use group policy objects. But another reason we're talking about it is for remote execution of PowerShell scripts. So using group policy, I can apply dozens, or actually hundreds, of PowerShell scripts to my organizational units and my groups of computers. And now when a machine boots up or when it refreshes group policy or a user logs on, well then at various times, these PowerShell scripts will be downloaded from the domain controller and run on the machine. Here's an example. On my computer, let's imagine that I have a script that I want to run on every machine in the domain. This is just an example. You don't have to follow along. In the day one folder, I've got a script called block Cortana. And when you run that script, it disables Cortana and adds firewall rules so that it blocks all the network traffic of the Cortana application. This makes it more difficult for Microsoft to spy on us. So in File Explorer, I right-click on that script and I copy it to the clipboard. Now, I go back to my Group Policy Management console. There's that enforced GPO. I could apply it to every machine in the domain. Or what if I only wanted to run that script on the machines in Boston? Well, in this case, I right-click on the Boston GPO, Edit, I now go to Computer Configuration, Policies, Windows Settings, and Scripts. Again, you're going to do this in a lab in just a moment, so if you're following along, feel free, of course, to follow along, but you're going to do it in a lab in just a second. Now when I come down to scripts, I can see on the right-hand side, startup and shutdown. Startup scripts run, of course, at startup, before a user logs on, and shutdown scripts run when you do a normal graceful shutdown of the machine. In this case, I want to run it as a startup script. So I double-click on Startup. The PowerShell tab is only for PowerShell scripts. The Other tab on the left, that's for all the other types of scripts, like VB script, JavaScript, or batch scripts. Now, I've got a PowerShell script, so I go to the PowerShell tab, I click the Add button, and then, very importantly, I need to click Browse. Because when I click on the Browse button, that takes me to a shared folder on the domain controller. I now right-click in a blank area here, I right-click and I paste that script file into this shared folder on the domain controller. I now select the script, click on Open, the name of the script appears. If I need to pass in any parameters or arguments, I can type that in here, but in this case it doesn't need any arguments. I click on OK and Apply. And that's it. I've now applied that script as a startup script to all the machines in Boston. The next time those machines reboot, they'll contact the domain controller, download this script, and then run the script automatically. I can keep on clicking Add here over and over again. I could add literally hundreds of scripts to the list if I wanted to. And you could have a mixture of PowerShell scripts, and on the other tab, all the other types of scripts that you want to run as well. So let's say that you've installed a Python interpreter on all your machines. Well, then you could run Python scripts too. We also have shutdown scripts. And inside the GPO, if I go to User Configuration now at the bottom, Policies, Windows Settings, and Scripts, notice that underneath User Configuration, we also have Log On and Log Off scripts. Now those dialog boxes, they look exactly the same. So if I were to double-click on Log On, I get the exact same looking dialog box, but these scripts would run at Log On. And of course the Log Off scripts run when you do a normal graceful log off. Very importantly, the startup and shutdown scripts run under system context. That means they run with full operating system privileges. So if you need a script to do things like format hard drives, load and unload device drivers, reset passwords, manage wireless, VPN, or Ethernet settings, that can be done with a startup or shutdown script. That's because those scripts run under system context. Now, by contrast, the log on and log off scripts, those run as the user. So if the user is not a member of the administrators group, those scripts will be limited in what they can do. But on the other hand, it is very handy to run a script as the user, because now the script will have access to the user's files and emails and anything else that the user has access to. All these scripts run hidden in the background. You can run them visibly in the foreground if you want to, but almost always it's better to run them hidden. Imagine that you have 10 startup scripts. You can run them synchronously, which means one at a time in single file, or you can run them in parallel. In other words, if you had 10 startup scripts, you could launch 10 interpreters, run them all at the same time in parallel. All these settings are configured through group policy, and in your manual it shows you where to go to set these options. And for example, you could get rid of the timeout so that a script could run indefinitely if that's what you want. So normally we think of like startup or logon scripts as just running for maybe a few seconds at the most and then they go away, but you don't have to have that. Imagine that you have a startup script that runs hidden in the background and that just runs 24/7 all year round. It might have a little while loop inside the script, so it just loops through a block of code over and over again. And inside that block of code, we have the start sleep command to make the script sleep for, let's say, 5 minutes. So every time the script runs, it'll do something useful. It then sleeps for 5 minutes, loops back over, and then does it again. And while the script is sleeping, it consumes basically 0 CPU cycles. In some ways, running scripts like this is more scalable and more fault-tolerant than using PowerShell remoting or SSH. Because remember that with remoting or SSH, you are actively sending packets to the target machine to do a TCP three-way handshake. But that machine's got to be running. There can't be any firewalls in the way. Now, group policy, on the other hand, group policy has a pull architecture. The domain controller just patiently waits for that machine to power up. And when it powers up, whether that's tomorrow or a month from now, when it powers up, it connects to the domain controller and then downloads its startup scripts. The scripts that we post into that shared folder on your domain controller will be automatically replicated to all the controllers in your domain. So literally, you could have 100,000 computers in your organization scattered over 200 sites around the world. And with just a few mouse clicks, you could make these changes. After several minutes, the scripts and the changes will be replicated to all the domain controllers around the world. And then the next time machines reboot, they'll download their startup script. So it's not as fast and immediate as PowerShell remoting or SSH, but in some ways, though, it is more scalable and fault-tolerant. You could run a startup script or a logon script like this on 100,000 machines. In this little lab, we're going to apply a script to the box. In this case, it's going to be a logon script. I wanted to do a logon script so it could pop up a graphical dialog box so that you know for sure, when you see that pop-up graphical dialog box, you know for sure that the script ran. But the steps that you go through in the lab are basically identical, whether it's a logon, logoff, shutdown, or startup script. It's just a different dialog box, but otherwise the steps are basically the same. There's an even better way of running PowerShell scripts through group policy. Now, before we see it, let's talk about group policy preferences, because the way that we're going to run PowerShell scripts is through a GPO preference. A GPO preference is what you find underneath the preferences container inside of a GPO. So, for example, I've gone to the group policy management snap-in. I'm now right-clicking and editing the Boston GPO. Inside this GPO, and in fact inside of any GPO, I can now go to Computer Configuration and Preferences. Underneath Preferences, you'll see dozens of subcontainers for really useful settings. For example, if I go to Files and Folders, I can sync the contents of a shared folder on the LAN with a local folder on every workstation to which the GPO applies. So, on the first day, we were talking about the profile scripts that PowerShell has. Using group policy, then, you could put the profile scripts that you want everyone to have into a shared folder, and then you could use this group policy preference setting to take the contents of that share and overwrite the profile scripts on the user's hard drive. So the user's own personal profile scripts, they can create and edit those, but the all users scripts, the scripts that apply to all users who log on to the machine, we could centrally manage those using group policy. Let's imagine I want to set an environmental variable. In fact, later this week, we're going to do this for the sake of AppLocker and what's called your PowerShell constrained language mode. I right-click on Environment, New Environment Variable. This is just one example. Now, down below, I type in the name of the variable and the value I want to assign to it. Pretty straightforward. But the main reason I wanted to show this is not because it's an environment variable. I wanted to show the Common tab. Because imagine that we want to set that environment variable, but only on Windows 10 machines that have a particular IP address and have a particular software package installed, let's say like Adobe Reader or Firefox. Well, all these GPO preferences, they all have their separate common tab, which allows me to go to item level targeting. I check the box for it. Targeting button on the right-hand side. And now I can pull down a list of criteria that the machine has to match before that change is made to the machine. For example, I pull down the New Item menu and I select Operating System. Now in the list of operating systems, I could choose Windows 10. That means this environment variable will only be created or set on machines that are running Windows 10. But I can keep on pulling down that New Item menu over and over again, adding additional criteria to the list. For example, I could specify the range of IP addresses that the machine has to fall within. Or if I go to MSI product, I could paste in the product code from the MSI package that was used to install, for example, like Firefox or Adobe Reader. And I can keep on pulling down the menu over and over again, selecting more and more criteria. We see the word "and" in between each of these criteria. That means the machine has to match all of them. But if I pull down the Item Options menu, notice that I can select "or." So if I put the word "or" between each of these, then you only have to match at least one of them. And of course I can do anything in between. I can mix and match the "ors," "ands," and "nots." So for example, if I select the IP address range and I select "is not," well, now this applies to machines that have an IP address outside of the range, not inside the range. Exactly what are we impacting here? Well, when I click on OK, just remember that we're looking at one particular setting, in this case for managing an environmental variable. So these are not selection criteria, these item level targeting criteria. These are not selection criteria for the entire GPO, it's only for that one single setting. For example, if I went to, how about INI files? Imagine that you had an ancient application that still uses INI files. Well, I could right-click, go to New INI file, define all the settings for that INI file, and notice that it also has a common tab, and it has item level targeting for just that INI file change. We don't find item level targeting for every setting inside of a group policy object. You only find it for the settings underneath the Preferences folders. And you'll find preferences underneath Computer Configuration and also User Configuration. Now, why is this so important? It's because one of your preferences is for managing scheduled tasks. And a scheduled task can run a PowerShell script. Let's take a look at it. I'm back inside the Boston GPO. I've gone to Computer Configuration, Preferences, Control Panel Settings, and now down to Scheduled Tasks. If I right-click on Scheduled Tasks, I can go to New, Immediate Task. Now, an immediate task is a scheduled task that runs immediately and only once. In other words, it's for command execution. So an immediate task runs immediately and only once. Now, by contrast, if I select a normal scheduled task, at least for Windows 7, we don't want to run dead operating systems, so I select scheduled task at least Windows 7, this is for running a PowerShell script on a regular recurring basis. So I select scheduled task at least Windows 7. Notice at the very top, I can create, replace, update, or delete scheduled tasks. So I can do all of my scheduled task management through group policy this way. Now I could give a name to my scheduled task. Imagine that I wanted to, kill unwanted processes. So I could have a scheduled task like Process Reaper. And when I run my scheduled task, I can click on Change User, type in the word System, and when I click Check Names, notice that it accepts it. And when I click on OK, I'm not prompted for a password. That means my PowerShell script is going to run under system identity. It's going to run with full operating system privileges. And that means my PowerShell script can do anything. When that script runs as system, It can do things like format hard drives, create user accounts, reset passwords, stop and start services, manage firewall rules, anything. Later on this week, we're going to talk about user account control. So I'm going to check the box Run with highest privileges so that none of the powers of the system identity are stripped away. When I go to the Triggers tab, that's what determines when the script runs, what triggers the execution. So when I click on New on the Triggers tab, of course we can run a scheduled task on a schedule. No surprises there. I bet you've created scheduled tasks before in the past, so this is not a surprise. But notice, you can also run a script at logon. Now normally we associate a logon script with a user account, and as that user walks from machine to machine, that user's logon script follows the user around from machine to machine. But this, on the other hand, this is a user logon script associated with a computer. So no matter who logs onto this machine, they now have an additional logon script on top of their normal one. You can also run a script at startup or on idle. Idle doesn't mean 0 CPU cycles, it means no mouse or keyboard input. For example, I could specify that, how about after 500 minutes of no mouse or keyboard input, the scheduled task runs the script. 500 minutes, what does that mean? It means the user has gone home. It means it's probably the weekend. But just in case the user is working in the middle of the night or throughout the entire weekend, well, the scheduled task won't trigger because the user continues to touch the mouse and keyboard. And one of the most useful options, I can select on an event. The task scheduler can watch over the event logs. So I pull down the log menu and I can select, for example, the security log. Now I pull down the source menu, if it lets me, there we go. I can pull down the source menu and, for example, select local security authority and then type in an event ID number. So when event ID number 5426 is written to the security log, that's what triggers the PowerShell script to run. Imagine that you had dozens of PowerShell scripts that are triggered by dozens of different event log messages. You can implement an entire host-based intrusion detection this way. You could do threat hunting, auditing, all sorts of things. So this is one of the most useful features of the Task Scheduler service, being able to run a PowerShell script in response to an event. You can also run scripts, for example, on workstation lock or unlock. So when you lock your desktop, nobody can use the mouse or keyboard to interact with your desktop until after they authenticate. However, your machine is still sending and receiving packets. But imagine that you have a PowerShell script that runs on workstation lock that blocks all inbound and outbound packets, and then you have another script that runs on workstation unlock, which then allows inbound, outbound packets. In fact, later this week, when we talk about scripting the Windows firewall, we're going to see a script that does exactly that. You can have multiple triggers on the list. So if you want to run a script at startup, every 2 hours after that, and whenever a particular event is written to the system log, you could have 3 triggers running that script at 3 different times. And you're not limited to just one script. If I go to the Actions tab, I click on New, I would now give the full path to PowerShell.exe and then the path to the script to be run. But you can add multiple actions. In other words, you can add multiple scripts to the list. So when the scheduled event triggers, you could have that run a dozen scripts. And finally, we have the Conditions and Settings tab, and this allows you to have more precise control over when the scheduled task will run. For example, on the Conditions tab at the bottom, I can check the box and specify that the scheduled task should only be run if at least one network connection is alive. Or if I have VPN tunnels on my machine, if I had any of them, I could pull down the menu, select the name of that VPN connectoid, and now the scheduled task would only run if that VPN is alive. I could also check the box to wake the computer to run the script, and then the last thing the script would do is to put the machine back to sleep again. On the Settings tab, we could allow the task to be run on demand even by users who are not administrators. We saw this in the first manual. Using PowerShell, you can create, manage, and also trigger scheduled tasks. So imagine that you create a scheduled task that runs a script with system identity, maximum possible power on Windows. I allow the task to be run on demand. I then use group policy to add a shortcut to the user's desktop so that when the user double-clicks the shortcut, the user doesn't know it, but he or she is triggering the scheduled task. A scheduled task that runs a script as system. That's another way of doing something like setuid root on Windows. And finally, because this is a GPO preference, I have a Common tab. I can go to Item Level Targeting, check the box, and then I click the Targeting button. Now I can pull down a list of criteria that the machine has to match before the script will run on the computer. So of all the different ways that you can run a PowerShell script, the Task Scheduler provides the most flexibility. And through group policy, we can create, manage, and delete scheduled tasks. In other words, we can configure these scheduled PowerShell scripts across tens of thousands of boxes relatively easily. And we have all the targeting capabilities of group policy at our disposal. We can apply different GPOs to different OUs. We have GPO permissions, block inheritance, enforced, and now also again we see item level targeting. That gives us a great deal of precise control over where these PowerShell scripts are going to be run. As I demonstrated that, I showed how you could run a script under the system identity. Now I keep on using the word identity because, well, the system identity is not a user account. But it is an identity that the operating system accepts. It has no password. It has maximum possible power. Most operating system processes run under the system identity. The reason this is important is two things. First, when you run a PowerShell script as a scheduled task, running as the system identity, it has maximum possible privileges. So whatever you need that script to do, there won't be any permissions or privileges or rights that get in the way. If you can script it, it'll work. But the other important thing about this is that the system identity has no password. And because it has no password, the password or the password hash cannot be stolen. And you don't have to worry about changing that password either, because it doesn't exist. Now, on the other hand, what if the script that you need to run doesn't require any elevated privileges at all? Well, in that case, there's another built-in identity. It's named local service. The local service identity also does not have a password, but is very low powered. It's about the equivalent of the guest account. So, in general, we want to run our PowerShell scripts with the least privileges that still allows the script to run successfully. And if your script doesn't require many privileges, then run it as local service instead. In fact, the local service identity is so low privileged, it can't even authenticate to other machines over the network. Your PowerShell script is more or less trapped on your machine. What if you did need to authenticate to another machine over the network? Well, in that case, you could run your PowerShell script as network service. The network service identity also does not have a password because it's not a real user account, but it's just a little bit more powerful than local service. The network service identity is permitted to authenticate to other machines over the network. So if you had a script that needed to upload and download files from a shared folder, or query a database, or talk to an Exchange server, then you could use the network service identity. Now the question is, when a script running on my box authenticates to your machine over the network, how does it authenticate? Well, on my machine, the script is running as network service. But when my script authenticates to your computer over the network, my script logs on with my computer account. So if the name of my machine is Box47, I've got a computer account in Active Directory named Box47. And when the script running on my machine authenticates to you, it's going to authenticate to you as Box47, namely as my computer account. It's important that we know this because what groups is my computer account a member of on your machine? Most likely, my computer account is not a member of the administrators group. However, it is a member of the authenticated users group. Now, despite the name, authenticated users, the authenticated users group includes both user accounts and computer accounts. So if you have a shared folder, for example, that's shared full control to the authenticated users group, then that means you're also sharing it to computer accounts in the domain. So when a PowerShell script running as a scheduled task on my computer, it runs locally as network service, but when it authenticates to your machine over the network, it logs on with my computer account. Again, why is this so important? It's because of the lack of passwords. These three identities on the top of the slide, local service, network service, and system, these are not real user accounts. They don't have passwords. And that means the passwords can't be stolen, they don't exist, and you don't have to worry about updating or resetting them because they don't exist. This is important because later on, if my machine becomes compromised by hackers or malware, the hackers or malware will be able to extract passwords for services and scheduled task accounts. But because these identities have no passwords, the passwords can't be stolen. They don't exist. Now, while we're on the topic of security, whatever your scheduled task is executing, whether it's a script or binary, we got to secure that script or binary. So you might place it into a shared folder and run it over the network instead of from the local drive. And wherever that script or binary is, don't forget NTFS permissions and NTFS auditing. Later on this week, we're also going to talk about how to digitally sign our PowerShell scripts, and then use tools like AppLocker to restrict the execution of scripts based on their digital signature. If you have a mobile device like a tablet or laptop, it's also a good idea to use whole disk encryption like BitLocker and UEFI Secure Boot. From a management perspective, if you intend to use lots of scheduled scripts, then you might consider having a dedicated scheduled tasks server. That machine could also be, for example, a DHCP server or a DNS server, so it could play multiple roles, but this could also be a place where you could centralize as many of your scheduled tasks as possible. For example, you could have a scheduled task that uses PowerShell remoting to run scripts remotely on other machines. And that scheduled task server then could be a central location where you have all these scheduled tasks and where you do all your logging. Not required, just a recommendation. So how do you choose the identity under which the scheduled task runs? Then I'll edit that GPO. I go back down to where scheduled tasks are managed. Now I right-click, I create a new scheduled task for Windows 7 and later. And in the middle here, where it says change the user or group, I click on change user, and now, for example, if I type in the words network service, and then click check names, notice that it accepts it, and I'm not prompted for a password. Or if I click on change user, and I type in the word system, again, it accepts that. That's the all-powerful system identity. And if I click on change user, and instead I type in the words local service, now this is the built-in identity that has the least amount of power. It can't even authenticate to other machines over the network. In this lab, we're going to create a scheduled task that will terminate unwanted processes. And this scheduled task will run 24/7 in the background. So this is a scheduled task that's going to run on your machine now forever. And whenever you launch one of the unwanted evil processes in the list, you'll see the list of evil processes in the lab, then within 60 seconds, the script is going to terminate it. Stepping back for a second now, let's think about what we're doing using PowerShell remoting, SSH, And now, scheduled tasks. We are running scripts potentially on thousands of machines in the organization. Now, when you run a script on the machine you're sitting at, you can see the output of the script inside your command shell. Or you could save the output of script to a file, and that file is right there in your local drive. But when you're running scripts across thousands of boxes, how do you get the output of the scripts? How do you get feedback? A nice way of gathering feedback or output from your scripts is to have your scripts send syslog packets. So you probably have a SIM or a syslog server. All security event management systems, all SIMs or SIEMs, support syslog, or they should. You have a script on your flash drive called send to syslog that has a function for sending syslog packets. So this is a quick, easy, dirty way of getting feedback from thousands of boxes. You can just send those plain text little UDP packets. Now, on the other hand, what if you do have an event log monitoring agent already installed on your machine? You've got like Splunk or Logarithm or ArcSight, or one of these products. Maybe there's a service or a driver installed in your box that watches over your event logs and then forwards the event log data to the centralized SIM. Well, in this case, you don't have to send syslog packets yourself. Just write to your own local event logs, and then you can rely upon the SIM agent to pick up that event and then forward it over the network to the SIM server. And there's a built-in commandlet for this. It's called write event log. Now, what if you needed to gather megabytes of data from each machine? Well, in this case, you could gather that data, put it into one or more files, and then upload those files to a centralized server. And you could upload files using protocols like SMB, that's the file and print sharing protocol. Or if you wish, you could use SSH for secure copy. Or how about WebDAV over TLS? Or FTP over TLS? There's scriptable command line tools for all these things. Remember that if a scheduled task is running as network service or as system, by the way, it can authenticate with its computer account over the network, like to access a shared folder and upload files. Another way you can upload files is through PowerShell remoting. PowerShell remoting is not just for remote command execution. You can also use this to upload and download files. And PowerShell remoting traffic can be encrypted with TLS, or if you have PowerShell core, with SSH. Another way that you can send log data is to set up an ELK server, ELK. ELK stands for Elasticsearch Logstash Kibana. You can set this up for free. You can set up your own logging server, and now your PowerShell scripts can send log data to that server for consolidation and reporting and dashboards and that sort of thing. For example, built into PowerShell is a commandlet called invoke web request. So you could take log data, convert it to JSON format like we did on the first day, and then you could send that over an HTTPS connection to your ELK server, your Logstash server. Or for that matter, you could send that HTTPS request to just any old web server, and on the web server, log the requests. And now you could extract out of the log files on that web server the data you're looking for. You could even send yourself emails. So built into PowerShell is a commandlet called protect CMS message. You could encrypt a file using that commandlet, attach that encrypted file to an email, and then email it to yourself. In fact, later this week, we've got a couple labs where we're going to use protect CMS message. And how about sending alerts or warnings to the security team? How about intrusion detection, incident response? Now you need to receive real-time or at least very fast alerts. You can script the sending of SMS text messages. And if you want something more secure than SMS, think about a scriptable client for something like Signal or Slack. So everybody on the security team could use Signal. You could have a script send messages to Signal. Or if you want more team collaboration, You could use something like Slack or Microsoft Teams or other similar products. Now everyone on the security team logs on to a particular security channel, and you could have scheduled scripts running on your boxes. And when something interesting happens, it's the script that uploads the file or posts the message to that chat channel. All right, so when we start running scripts across thousands of boxes, we have to think about how to gather the output of the scripts, whether it's for troubleshooting, auditing, forensics, or for any reason. So learning PowerShell is more than just learning the syntax and running the scripts locally on the machine where you're sitting. Learning PowerShell also means learning things like remoting, SSH, group policy, scheduled tasks, and now on this slide, techniques of gathering the output of scripts when you run scripts across thousands of boxes. And this is just what I could fit on the slide, by the way. I mean, if your organization is a cloud-happy organization, think about forwarding log data to a cloud service in Amazon Web Services or up in Azure, a cloud service designed for IoT devices. And now you could use things like, if you're familiar with Microsoft's Power BI, having a beautiful interface, a graphical interface, for querying all that log data consolidated up in the cloud somewhere. And by the way, Power BI is itself PowerShell scriptable. All right, so now this is kind of hopefully pushing your horizons as you start thinking about running PowerShell scripts, not just on a few machines by hand, but across thousands of boxes. And that is it for the manual.